So first off, a quick little reminder about how to factor a sum of perfect cubes. So you'll have 2 terms and then 3 terms. Now think about what you cubed to get x cubed and what you cubed to get 8. Those two numbers are your first 2 terms. Then I'm going to square that x and have x squared, square my 2 and have 2 squared, and then my middle term is 2 and x multiplied together. My signs are same as what I had, opposite, and then always a plus. So this ends up factoring into x plus 2 times x squared minus 2x plus 4. So we're going to be simplifying a lot of rational expressions, which are basically fractions with variables in them. Just like numbers, if you have a common factor, you want to divide it out. So I can think of as like 18 as 3 times 6, and I can divide a 3 out of that to reduce it to 1/6. I'm going to do the same thing with each rational expression, which means I'm first going to factor them because right now they are individual terms being added or subtracted. I can't divide out anything unless I have a common factor of all of my terms. So to see what common factors I have, I need to actually factor. So on top, I'm looking for two numbers that multiply to 16 and add up to -8. So I'm going to use -4 and -4 to rewrite my 8x in the middle. And then I could factor an x out of my first 2 terms and a -4 out of my second 2 terms, which means that's going to factor into x minus 4 times x minus 4 on top. And then on bottom, quick little reminder, that's a difference of squares where it's x squared and 16 is 4 squared. So those always factor into 1 plus and 1 minus factor. So x minus 4 times x plus 4. Now any common factors that I have, now that it's all multiplication, can divide out to 1. So I'm just going to end up with x minus 4 over x plus 4. And that's as simplified as it goes because those individual terms share no common factors. Remember, factors are things that are being multiplied together, not added or subtracted. Now on B, if I look at the top, I can factor out a common factor of 2x to start with. So let's factor a 2x out, which will leave me with x plus 5. On bottom, I'm looking for two numbers that multiply to 3 times 5, so to 15, and add up to 16. So I'm going to use 16 and 1, or 15 and 1 to rewrite my middle term. And then I'm going to factor out, I'll just write it down below here, factor 3x out of my 3x squared plus 15, and just a 1 out of my x plus 5. So that bottom's going to factor into 3x plus 1 times x plus 5. And then I've got my top. And you can see I've got a couple common factors of x plus 5 that will divide out to 1. And you'll be left with 2x over 3x plus 1. Now we're going to do a little bit of multiplying and simplifying any common factors. So we've done these before actually. You can just multiply your monomials straight across and then add your exponents and then look for common factors, like you can reduce 135 over 75 if you think of them each as like 9 times 15, I think, and then 5 times 15. They both have a common factor of 15 that you can divide out to 1. And then if you subtract your exponents, you'll have 2 factors of x left on top. And then same idea on my y's, there will be 2 factors of y left in my denominator. And you end up with 9x squared over 5y squared. Or you could reduce before you multiply and divide 5 by 5 and 25 by 5 and make it 1/5, and 27 and 3 by 3. That way it's a little bit easier to simplify your numbers. And then you could go ahead and simplify your variables and end up at the same spot. So here though, look at all these multiple terms. I've got 2 terms times 3 terms. You do not want to like distribute and multiply this all together. Factor each group and then divide out your common factors like we've been doing. So I could factor a 5x out of that 20x minus 5x squared. And then on bottom of that first one, I could factor out an x, leaves me with x minus 1. And then in my second fraction, I'm going to factor that x squared plus 3x minus 4 needs to multiply to -4 and add up to 3. So I'm going to go 4x minus 1x. And then factor out an x and a -1. So it'll end up factoring into x plus 4 times x minus 1. On bottom, we did this one earlier. It's a difference of 2 squares. So that'll be x minus 4 times x plus 4. Now I could just squish it all into one single fraction. since it's all being multiplied straight across there, and look for common factors that'll divide out to 1. So my x minus 1s will divide to 1, and so will my x plus 4s, and also those x's. So I'm just left with 5 times 4 minus x and x minus 4. Now those are real similar, actually. If you pull a negative out of either the top or the bottom, those factors are gonna match each other because they just have their sign switch. So if I factor out a -1 and make that a -5, it'll switch to a -4 plus x, which will divide out with my positive x minus 4 that I have on bottom. So that whole messy thing just simplifies all the way down to -5. So here we're looking for a couple of ratios of surface area to volume for each of our 2 types of canisters that this company is making. So ratio of surface area to volume is really just what proportion I get when I divide my surface area by my volume. So if we do style number 1 here, it's got a surface area of 4 pi r squared and a volume of pi r cubed. So if I simplify, I can divide out my pi's and 2 of my factors of r. I'm just going to have 4 over r for my ratio of surface area to volume on that style. And then for my second one, it's 6 pi r squared for my surface area and 2 pi r cubed for my volume. So set it up again, reduce that fraction a little bit, and I'll end up with 3 over r for that proportion.